Here we're going to look at the acid-base properties of oxides. I'm going to demonstrate the different experiments for you. Have your practical sheet ready and record your observations as we go. So first of all, we are looking at section 1, what is a base? So for part A, we're going to add a spatula of calcium oxide. There we go, white powder, to a beaker of water. I'm going to add my distilled water in there. And we're going to test the mixture formed with universal indicator. So calcium oxide doesn't dissolve brilliantly, so it's still quite cloudy there. But with our universal indicator in there, we can record the colour. And then we can use the pH chart here to decide which corresponding pH we're going to have. So record your colour, record the pH value that you choose, and then answer the question, is calcium oxide a base? So in part B, we need to collect some dilute hydrochloric acid in a test tube. So I have my test tube, hydrochloric acid here. And then I'm going to put universal indicator in and add a spatula of magnesium oxide. Oops, spilling there. Okay, so hopefully that colour was as expected for our hydrochloric acid. Then our magnesium oxide. So we put a spatula of this in to start with. And shake. So we can't see any change here at the moment. And if you look, we can still, oh, actually no, it's going there now, isn't it? I was going to say we still see quite a lot of solid, indicating that the reaction hasn't taken part completely yet, but it's starting to react away now. So I think we can get away without warming this one. So note down the colour changes that you see. I'll put this in the test tube rack and then we can have our colour chart next to it. So choose the pH that you think you've got at the moment. While we do part C, I will actually just leave this one and see if we get any further change as well. And you can already record the answer to the question, is magnesium oxide a base there? So in part C, we are going to take some more hydrochloric acid, but this time we're going to add zinc oxide. So my hydrochloric acid there, again with some universal indicator. And now we have our zinc oxide. So give this one a shake again. And we observe any changes there. Now it's quite kind of cloudy there because of the zinc oxide that hasn't reacted. So we'll let that settle out a little bit before making final conclusions about the actual colour. But hopefully we can see quite straightforwardly the change from the red colour initially. I'll also just take a minute just to heat both of these, just to ensure we get the maximum amount of reaction possible. So over at the Bunsen burner here, just gently heating the hydrochloric acid with zinc oxide. I've only got a small volume, so I don't want to heat it too much. I don't want to spoil over. Right, that'll do for heating that one. I'm also just going to heat the one we were looking at previously as well, just to make sure we get no further change in that one. Okay, so this is just heating number 2. We said we'd leave it for a little while and then give it a heat, so just give it a chance to show the maximum amount of reaction. Alright, I'll stop heating there again before that one bubbles over. Okay, so we have both tubes back on our test tube rack now. So this one was part C. Okay, so record your final pH here. And then we said we'd just revisit part B after heating as well. So you can just see if you are happy with the final pH that you recorded earlier there. So this one's part B. Now for part 2, we're looking at what is an acid. So in A, we're making some carbon dioxide by putting sulfuric acid in a test tube and then adding some sodium carbonate. So think about your typical acid reactions. Acid plus metal carbonate gives us, and hopefully you're thinking of salt, carbon dioxide and water. You could be thinking also, if we have sodium carbonate and sulfuric acid, which salt are we going to be producing? Almost went over there. Not quite. Right, we're going to capture this gas and then bubble it into some distilled water. Take a little bit out of there. That has some universal indicator in, and we'll see what happens. Okay, now when we're trying to collect our gas here, if I just now suck up over the surface of the solution, this test tube is going to be nice and full with the gas from all that whooshing before. So we should now be able to squish this up and down, and then look at that. So record the colour change, so what the universal indicator has changed to. And then here we go with the colour chart again, so you can record the pH that you think here. Let me just move that a bit further forward for you. Okay, so decide what pH we're going to record there. Remember that if you think it's kind of midway between like that red and that orange, you can record a pH 2. It doesn't have to be only 1 or 3. Okay, so you've got the whole scale to use. Then you can answer the question, is carbon dioxide an acid? Then in our next part, we're going to do a similar experiment, and this time we are going to make some sulfur dioxide. So I'm going to get my water ready before this time. Again, a little bit too much there. Put my indicator in. Okay, so we have the sulfuric acid going in there. And spatula of sodium sulfite this time. So sodium sulfite. So to remember the formula of the sulfite ion as opposed to the sulfate ion. A little extra in them. So sulfite is SO3 2-. and sulfate is SO40 minus, so this was sulfite. Okay, so it's much less vigorous reaction than previously, but we should still be able to suck up over the surface of the solution. Look at that really nice quick change there. So again, record the colour and the final pH, and then we can decide if we think that sulfur dioxide is an acid. So our last experiment is part C. So we're going to add a spatula of phosphorus oxide, P2O5, to a small beaker of distilled water, and then again test the solution with our indicator. So there's our small beaker of distilled water, and this is our phosphorus oxide. This is nasty, this stuff. So we just add a small amount here. Did you hear that? Let me do one more small amount. Okay, so we get a very vigorous reaction there, hence the hissing. Let's get that last bit in there as well. And then the universal indicator. So you might think ahead, what do you expect from our phosphorus oxide here? There we go. I'll move this above, it's quite fun seeing the indicator change. So as it disappears out, the red, the green just disappearing out to the red. There we go. Okay, so we need our universal indicator chart once more. So record the colour and your chosen pH for this one, and then we can decide if phosphorus oxide is an acid as well. So check through your results of both experiments, make sure everything is complete, and then ensure you go ahead and answer the questions and write equations for the reactions that occur.